Hello everyone, welcome to Live from the Lab. This is the show where we talk about different technologies that Bruker's developed to help scientists around the world make new discoveries. Today's episode is about single crystal diffraction, in particular our Apex-5 suite of different software tools, and one of the most important new additions. Now you could go to all the work of making those structures, or making the crystals, then measuring the structure, refining it out, but what do you do at the end? That is the question that we're going to be solving today. In order to do that, we've got an expert here in the studio, along with some of the actual software writers in a video. And as always, we're going to answer your questions live as they come in. So as you think about it, you can go ahead, always type those in on the side of the screen. But enough beginning, let's head on over and start our discussion. Good morning, Michael.
Good morning, John.
Thanks for joining us.
Always nice to be here. Thanks for having me.
All right. Thanks, everybody out there, for joining us. Today, our topic, like I said, it's about single crystal diffraction. This is something that definitely out there has the vibrant user community. I know that you guys have fostered.
Yes, we will be talking about CIF today. So that's the crystallographic information framework.
So CIF.
CIF, yes, correct. So typically in these shows, we talk about exciting technologies, new hot sources, great detectors, or we talk about really interesting applications. Today, we will be talking a little bit more about the nitty-gritty, the operational part of being a crystallographer.
Yeah.
So we all know it's exciting to solve a structure, it's exciting to refine a structure, but then you have to finish it all up. And this is sometimes where it becomes a little tedious. So what we will be introducing today is the implementation of FinalCif. It's in the name, basically finishing up your CIF file, and the implementation of that in Apex-5.
Yeah.
So the CIF, this framework, nowadays I probably would call it like an ecosystem, was developed by the IUCr, or a committee decided to develop the CIF standard in the early 90s, and it's under development. It provides a lot of tools for researchers to share their results, to provide the tools for reviewers to check your structure. The IUCr provides CheckCIF to upload your file. Yeah. Check it, you will get alerts if there's problems with the structures. So it provides a framework to make the dissemination of crystallographic information very transparent.
Okay.
CIF files are then deposited with the journals or uploaded to the database, to the CSD, for example, or the COD.
So I guess to break it down to the foundation, the CIF file then, this is when we see in single crystal, you got that floating molecule.
Yes.
Right? The most basic part of this file is going to be atomic positions, crystal system, and then the atoms.
Exactly. So there's different, let's call them tags. I just give you one example, and it's all sort of machine readable.
Yeah.
There is information that is provided by the user. For example, only the user knows what the crystal color is. In the CIF file, it would be _exptl for experimental. That's a section.
Yeah.
_crystal_color. And then you would provide a text in quotes. So the color itself, the IUCr has defined colors, so you can use purple, pink. You cannot use mauve, for example.
Okay.
And then there is, of course, as you said, the atomic positions. Those are loops, also bond distances. Then there is information about authors. There's information about the instrument. And they all go into different sections. And then a lot of the sections get automatically, of course, generated when you refine the structure. All the information about how complete the data is, to what resolution it extends. That is all generated automatically by the refinement program. But then you have to put in information about what kind of an instrument, the device type, which was used to collect the data.
Yeah.
All the information that is known by the system itself. In FinalCif, we'll grab these tags, this information out of Apex's database. We'll populate those. You can interact with it. in real time. You can type text. You can do from within FinalCif, you can do CheckCIFs, and then you can answer the alerts directly. So there might be a reason why you have an alert. There's not much you can do about it.
Right.
But you can answer the question, why is this the case?
Yeah, and that CIF file is so essential to that communication of your important scientific work and discovery to that rest of the world. I know when if we're looking at a new material in some of our software, we can import the CIF file, or we'll use a database, the COD, the ICDD databases, and these all depend on those tags being important. Of course, ICDD, they'll go through edit it, but then you're paying a price for that. Here, it sounds like a great solution to make sure, though, that your work as a single crystallographer is really going to be as applicable as possible out there.
So yeah, this is more about convenience.
Yeah.
Because we want the service crystallographer, we want them to focus on refining structures, solving structures, on the stuff that they actually enjoy. And I personally do not enjoy finishing up a CIF file. Once I see the structure pop up on the screen the first time, my excitement drops very quickly. And I guess that's the case with most of the crystallographers. So this is a great tool that makes the life of our customers easier.
Yeah.
And gives them more time to focus on the exciting stuff, the exciting side of crystallography.
Yeah, rather than being focused on what's the latest standard of the CIF file. Do I,
Exactly.
do I really have that tag right? Did I miss a bracket?
Yep.
Bam, we're good to go. So I guess we have a video though today, right, to see with.
So the author of FinalCif is Daniel Kratzert. He was a service crystallographer. He's a programmer. We hired him, and he will be giving a demo of FinalCif in Apex 5, and we'll have Tobias Stürzer, who is the head of applications in Karlsruhe, and they play tag team, and I think we should watch them give their spiel.
Yeah.
And be back and answer some questions.
Yeah, so we'll go to the video, and then, like Michael had said, if you have any questions while we're watching it, just go ahead and type those questions in, and we will get to those right after. So off to the video.
Enjoy.
Hi everybody, and welcome to our seminar on a new report functionality in Apex 5 based on the great program FinalCif. With me today is Daniel Kratzert, the author of FinalCif, and my colleague here at Bruker.
Hello everybody.
If we talk about the report functionality, we first have to think about where this functionality is actually important in the process of determining a single crystal structure. So usually it all starts with a sample, picking a crystal, you put it on the instrument, you screen it, determine the unit cell. If the sample is good enough, you collect data on it, then you reduce the data to an HKL file, you solve the structure based on that, you refine it, and you then get a nice structure out of it, and that's it. And actually that is not entirely right. You also have to make sure that everything you did is properly documented and reported. So you have to document the sample, the experiment, the software used to process it, and of course the final outcome, the coordinates, the term parameters, the unit cell. And all that is done in the established CIF format, the crystallographic information file. And maybe you, Daniel, can give us a little overview of what's actually in a CIF file.
Of course. We have here an example of an ordinary CIF file that was used for a single crystal X-ray diffraction experiment. And its refinement, it is what comes out from shellXL. It normally starts with a data tag and has a name behind. And the rest is essentially a key value store where you have keys like audit creation method that defines the version number of the used refinement program. You have chemical name common, for example, with a value which is a question mark. That means this value is currently not defined. So we need to define some values that are currently unknown. We have information where, for example, here the unit cell information where the numerical value also has a standard deviation in brackets, and then we can have text values with a longer text, which is more than one line. They will start with semicolon and end with a semicolon, and you can have longer text in between. And there are also loops that are essentially tables with a header which defines the columns of the table. For example, the atom site label is the label of the atom here. The atom site symbol is the atom symbol, and the coordinates of the atoms. And so we have rows of atoms in this table. So that's basically it, what the syntax of single crystal CIF file is about. And the order of the keys and values in the CIF file is from the program, from reading by programs, is not defined, or you can have it in any order, but it is common to have things that belongs together, grouped together. For example, here the chemical information about the structure, the scattering factors of the atoms, the space group information, the unit cell information, the crystal habit, like the color and description, and the information about the reflections, the amount of reflections and R values and so on, and which programs were used in the structure determination, and the quality parameters of the structure, and of course the atom parameters like the coordinates, the U values, bond lengths, angles, and so on.
Mm-hmm. Okay, thank you, Daniel. So this is an ASCII file, as I see, so it's readable with any editor, right?
Yes, you can, of course, edit it with an ordinary text editor, which is, of course, tedious work. It's a quite long file, and you can easily make syntax errors if you do it by hand. So it is not advisable to edit a CIF file by hand.
Mm-hmm. Okay, so if you look through the crystallographic databases and download these CIF files, if you want to see published structures, you will notice quite often that most of the CIF files are quite, or to some extent, incomplete. So sometimes really important information is missing, and sometimes just basic information like crystal size or color is missing, which is quite sad, actually. So apparently, submitting a complete CIF or creating a complete CIF seems to be quite a challenge for the crystallographer.
Yes, of course, and it also takes quite an amount of time. So in my work as a crystallographer, I came to the point that I wanted to have software that helps me with this work, and that gave me the idea to create a program called FinalCif to help me with this work and make all the time-consuming, kind of boring editing more quickly, and have possibilities to check the quality of the structure in the CIF file, and make this all faster and easier and more fun to do.
So from the feedback from the community, I mean, FinalCif exists now for how many years? 5, 6, 7?
Yeah, something like that.
So the feedback was very good. So it felt apparently really fruitful ground and really helps the people to prepare better CIFs faster. So what's your feedback on that?
Yeah, I got quite amount of feedback and quite amount of downloads from the program. And many users came with suggestions how to improve, and yeah, it is quite often used by crystallographers.
That's really cool. So it really grew on the feedback of the community.
Yes, yes.
And this program we have now available in Apex?
Yes, it's in the report tab behind me on the other side. We have the CIF report button. If I open that, it will open the CIF file, not as plain text, but as a table. And there we have three main columns. And of course, the CIF keywords that are displayed here. We have three main columns. The CIF value column, which means that is the value that is in the CIF file. You have the from data source column. That is the column where data is input from inside Apex or other data sources. And so that will end up in the final written CIF file. And you have a column where you can edit the data by yourself. One thing in addition to say about the table is that there's a line where below that line is the data that is already in the CIF, and above that line is data that is still incomplete, that either you or the software has to make complete in order to get a publishable CIF file.
Mm-hmm. So I see these yellow marked fields there. What do they mean?
Yellow in this case means that it is advisable to complete these data and in order to get a complete CIF file, and green means that it is already in. For example, you have the chemical formula moiety here that you should put into the CIF file. One more about the table here. If you click on one of the keywords, you get help about the corresponding keyword and
really
can see what you should put in there.
That is really nice. So before we go through that more in theory, I have a really nice data set I collected a while ago. So if you go back to the refinement plugin, we have a very nice gold compound. So thanks to Marco and Marcio from the University of Padua for providing this sample. So if you just refine that, you see the structure is done. We get excellent R values, R1 of 1 point something. So basically, I'm done with the refinement. And now I want to create a complete CIF out of that. Could you guide us through the new report functionality, how you would do this with this kind of data?
Yeah, the nice thing is that Apex collects during the processing of the data lots of information and stores that, and that all will automatically end up in the CIF file. So you don't have to find the version of BIS that was used to measure the frames or the name of the detector or which Saint version was used or so, or the number of reflections that was used to determine the unit cell. That is all automatically put into the CIF file now.
Okay. So also quite often common problem is that people forget to enter the instrument parameters or the instrument components that were used for measuring it. Is that also in now automatically?
Yes, that's automatically in there. If you open the sample directory, you will see that there will be a file that is called Bruker measurement configuration underscore the name of the target, in this case copper. It was measured with copper radiation.pcf, and that is basically a CIF file that contains all the information about the machine that was used to measure the data set.
Mm-hmm. Okay, that's really interesting. So what else do we have?
And that's also automatically put in there then.
Mm-hmm. So I've also seen that the experiment itself is also put in the CIF file?
Yes, it's here. And what else to say? Yeah, it of course displays the name of the CIF file. You can easily rename the CIF file if you think you want to have a different name. You just rename it, and all other things are done behind in the background, and it's all automatically. The space group is shown here. You can input the CCDC number if you have one, and the sum formula is shown. And
so, as I understood, then Apex just collects throughout the whole process all the parameters important during the structure determination, and automatically puts them all in there. Is that right?
Yes.
Oh, that's really cool. So if we go all the way up, what do I have to do now here? I mean, how many yellow fields are left? You move.
Not much. It's in this case it's a non-centrosymmetric space group, so we have to define how the absolute configuration was determined. We have the moiety formula. We have references for the publication and special details about the refinement. So essentially, not much. Four items.
That looks really, really cool. So that will make my day way easier.
Yes.
So for most of the crystallographers, of course, it's important in the end to make sure that the CIF is compliant with CheckCIF in the end. Is it also something you could do from here?
Yes, of course. There's below here is the CheckCIF button. There you have the choice if you want to do an offline CheckCIF, an online CheckCIF, either with an HTML report or with a PDF report. And let's say we want to have an online HTML report. We click on it. It will send the CIF to the IUCr server, and we get back the report. It takes a little while. The offline CheckCIF that is only done locally, so nothing leaves your computer, is a bit faster, depending on your computer, of course.
So that's already the feedback from the CheckCIF server?
Yes.
Okay, so what do we have in my CIF file? Is it all right?
I think it is saying that the Z value is not correct, so you should have 3 instead of 6.
Mm-hmm. Well, I put that in on purpose. That's good.
And so there's information about your crystal on top, and then there are so-called alerts with a certain level, and we have only minor alerts here. And the nice thing in FinalCif is that you can go to this CheckCIF alert tab, and then you can make responses to these alerts without copy-pasting text snippets. And
sorry for interrupting you. Just covering the interesting part. Yeah. Oh, you can directly comment on the alert. Oh, that's really good. And that will also go directly into the CIF then?
Yeah. If I click on Save Response Forms, it will save it. And if I go back to the main table, we have at the end the answer about the alert here.
Okay. So now we notice that the set is wrong. So if you go back to refinement and change it, could you quickly do that from 6 to 3?
Yes, that's the nice thing, that if you do changes in your structure and do not solve, refine, if you want to make smaller changes and do another refinement, and you go back to FinalCif, all the information that you previously put in is restored, and only the updated information is updated.
Okay, that's really cool. So for me as a service crystallographer here at Bruker, to some extent, it's of course also important that I provide all the necessary files together if I send out my data. So could you also do a CheckCIF and automatically save the PDF feedback?
Yes, of course.
Oh, that would
If I do here an online CheckCIF with PDF, I will get this PDF report. Takes a little while again. There it is. We have the CheckCIF report as a PDF.
my alert is gone.
Yeah.
So where, I guess this is stored somewhere. Where's all this stored?
It is in the work directory. There we have the PDF report, and it is also stored. The CIF file is then named after the project minus finalcif.cif. So it won't overwrite the original CIF from the refinement. It makes its own CIF file.
Okay, thanks, Daniel. So quite often it's also important to kind of create a little report on the sample I collected. It's also possible to automatically create a report similar to the previous report plugin we had in Apex?
Of course, you have two possibilities: either create an HTML report or create a docx, MS Word document. And from that you could also do PDF files. So let's start with the HTML report. We have here three predefined templates. You could of course create your own templates, but let's use the HTML report and click on Make Report here in the middle. And a short while later, you get a web page in your browser that shows you all the information about the experiment details, and of course also the structure.
Oh, they are interactive. Oh, that's quite nice.
And
so also the tables.
Yeah. And if you want to have a Word document, you choose the first template and make the report from that. And that gives you a Word document where you have all the information that you might want to give a customer also, or write a publication from.
So that means I don't even have to write the crystallography part myself anymore? The experimental one at least, it's all in there?
Of course, you should check if that every detail is right, but yes, most of the work is done by the program.
Okay. So I've also seen down there a button, deposit. So you can also directly deposit your structures from here?
You have two options. Either deposit directly into the COD, the crystallographic open database. There you have an interface where you first have to create an account there. If you have an account, you can put in your credentials and can directly publish a structure from here. The second possibility is CCDC deposit. There you are just guided to the website and can your deposition from the website.
Okay. Well, that looks like a very comprehensive plugin or very comprehensive tool to finish up the whole structure. I mean, if you, after you went through that, is there anything left you need to do?
Not really. So after that, you all have in hand what you need for publication.
Okay, so that goes even beyond the functionality of FinalCif as it is a standalone at the moment.
Yes, yes.
Okay. Okay, great. Anything else you want to show us today?
Maybe minor things like you could, if you have a CIF file which contains HKL and results file data, you could click on the extract HKL res file button, and you will end up, it will show you the directory from the CIF file and where it extracted the HKL and results file from the CIF. What else? You can select your own picture for the report with the Select Picture for Report button. You can edit authors that should inside the CIF file, where you have a mask, input mask, where you define all the information from the authors. Mm-hmm. And there's the Edit Loops button, where you can edit or just view all the loops or tables that are inside a CIF file in a more human-readable format.
Mm-hmm. Okay. Thanks, Daniel. That looks like a very, very comprehensive plugin to finish up structures. So basically that means you can now do really everything within Apex, from screening the crystal to finishing up the CIF file. Is that right?
Yes, of course. Okay. And I really recommend doing everything inside of Apex so that FinalCif at the end has all the information it needs to complete the CIF.
Okay. Then, thanks, Daniel, for this very nice introduction.
You're welcome.
This is now available in the latest Apex version you can download from Bruker support. If you have any comments or feedback, you can, of course, always directly contact the applications team, Daniel, or me. And we will have a Q&A session after this webinar. And so then, I thank you for listening and have fun with the new functionality in Apex.
Thank you.
All right, so welcome back to the studio. Great video there. Thanks for putting that together, everybody. So we do have some questions that have come in. If you do have any more questions, just keep typing them in and we'll answer them. Otherwise, if you're watching this later, send them in to live.events@bruker.com. So the first question that came in the live stream here is from Gustavo. Can the new plugin in Apex 5 suggest some author response for CheckCIF?
Some author response? No, that's not implemented.
Okay.
But I guess there are typical answers for, reflections behind the beam stop, or so maybe we could work on a library, and we don't want to make it too easy for people to get out of trouble.
All right. And then Gustavo has another question. Can I put the instrument information automatically with this new feature?
Yes. So what happens now is that there will be a instrument-specific file will be generated by the Bruker instrument server, and then that file will be read automatically.
All right. So depending on whatever collimator you have, what radiation you're using.
Exactly. Mm-hmm. That was always a little bit of a sticky point, that you had to provide that information yourself,
right.
Whereas the instrument should really know what it is.
Right, right. And it does know, right?
It does know,
yeah.
Yes.
Yeah, because you guys have that really cool feature where it does your limits and such based on that, right?
It's the good old Da Vinci.
Yeah. All right, so from Anna, is this included in the most recent Apex 5 download?
It's not. So we're in beta test, and we were hoping actually that we would have released the software Always takes a little longer, but it is in beta test, so the release of the next version of Apex 5 is imminent.
Okay.
And then you will get that feature with a free download.
Sure. And we actually have a question that had come in earlier from Murray. Is this upgrade free? So that kind of ties into it.
Yes, it's a free upgrade.
All right. So from Marco, what is the difference between this and the public version?
So they're very similar. So the nice thing about the version that is implemented with Apex 5 is that it will instead of looking at a lot of flat files that are generated where the free version receives data from, this will now come all out of the database. That really ensures data integrity, and it also makes sure that you always have the latest value, that you're not grabbing a value that was maybe determined at an earlier stage and then was refined later. So you're always getting the latest information out of the Apex 5 database.
All right, so that intimate connectivity with the software, that's going to give you the best results. All right, so from Christina, do I have to install anything else like Platon to make this work?
You have to, Platon is actually installed.
Okay.
When you install Apex 5, we have an agreement with Spec, so we install that. So it's basically a one-stop shop where you get Platon installed with Apex 5, and then Tobias and Daniel showed that you can either do a local check, so that would use Platon that is installed on your computer, or you will go out to the IUCr and do an online CIF check.
All right. From William, we have the question, how can I update my software?
So the easiest way is go to brukersupport.com, and you either have a login or your service crystallographer has a login, and that's where you can download the software. We now provide a what we call a one-click installer. It's not a one-click, it's like one file, and then you would typically accept all the defaults unless you want to do something special. But it's one file that you download, and then you start that executable, and it will install the latest version of Apex 5.
All right,
no
so
need to
you would download the
uninstall.
whole Apex 5.
Yep.
Okay.
That includes all the the environments, the Python environments, what we call the Bruker suite itself, and then all the executables. So it's really one stop.
All right. And sometimes I know you get like a notice if there's a new version. If not, just kind of keep checking. You said a few months from now.
Yeah. So there is a little flag, if you have seen that, in Apex 5, and it alerts you if there is a new version that can be installed, if you're connected to the internet.
Oh, okay. So that makes it really easy then to know when things are ready. And last question that came in before the broadcast, do I need an account with the IUCr to run this?
That's a good question. I don't think so. No.
There you go. Makes it easy. All right. Well, that is all of the questions that we've gotten. So thank you for joining us today, Michael.
Thanks a lot.
Yeah.
Always fun to be here.
Yeah, another exciting feature that we're always adding.
Yeah.
So
it's we have a great team. In all the development is basically done now in Karlsruhe. We have one lone developer here in Madison. It's a great team. It's a great group of people. Most of them have crystallographic experience. We're former users, so I'm really happy in with the direction the software development goes, and I hope you're.
Yeah, it's nice to see, though, that the software covers you all the way from the beginning stages of the measurements and such, all the way to this end, real final stage ready for publication. So, all right. And also a big thank you to everybody out there for spending your time with us, watching this show. So until next time, make sure to keep your signal high and your background low.
Happy refinement. Thank you.